morning. My name is Muhammad Alif bin Adam, B0919102008, BMMM S1/2. Today is our lab test BMM 2343. Bed friction. Bed friction is a term describing the friction force between a bed and a surface, such as a bed wrapped around a bullet. When a force applies a tension to one end of a bed or rope wrapped around a curved surface, the frictional force between the two surfaces increases with the amount of wrap about the curved surface, and only part of the force, our resultant bed tension, is transmitted to other end of the bed or rope. Bed friction can be modeled by bed friction equation. The below mathematical formula is used to calculate bed friction over a drum or cylinder. Beside the step-by-step calculation for each calculation performed by using this calculator, let the user to know how to perform bed and rope friction calculation. In the yield field of the mechanical engineering, while working with the frictional contact mechanism, that it is important to analyze friction characteristic. The above formula step-by-step calculation may be useful for user to understand how the value are being used in a formula to find the friction rope over cast storm. However, when it comes to online for quick calculation, this bed friction calculation help the user to verify such a mechanical calculation as quick as possible. So, in a bed friction, we use the capstan formula. T load equal to T whole E mu and theta. Experiment. Objective experiment to investigate the relationship and determine the coefficient of friction between the bed and the pulley for the rubber. So as we can see, this is a apparatus of bed friction from the front view and rear view. So we can see have a 10 apparatus that important to perform this experiment. First is cast iron pulley, the whole rope. Second, hand crank. Third is pulley support at the back. Fourth is a column. 5 is a swivel type bed holder. 6 is a locking pin. Locking pin is used for the setup for the degree. 7 is spring balance 1 in T1. Spring balance 2 is for the T2. And 9 is treated steam, and 10 is a base plate. The simple pulley is a wheel and axle with a rope or bed loop around it. As the rope is stuck, the pulley turn. The force on the rope travel around the pulley to other end of the rope. So the pulley change the direction of the force. If you were to attach a weight to the one side of the rope, the loop is around a pulley and a pull down on the other side of the pulley. The weight would lift up. It's very simple. The direction of the force of your tug is a change from down to up. So from this diagram, this is situation like all the rest of the equation of our equilibrium problem for the rigid body. So we are going to read the problem, draw the body diagram, and consider what the equation we have. In this case, we get one more equation for bed. So if we look at some vocabulary term, for any pulley with a bed or a rope going over it, we assume up till now that frictionless friction situation. So the tension on the both side is the same. As you can see, no friction, means F1 equal to F2. As soon as you actually have a friction on your bed, they are not same anymore. So from this picture you can see we have R as a radius of the pulley. So if you can see, I'm going to have F2 and F1 are two tension and they are different. So the bed is coming from over here, F2, and it's going this direction with F1. Beta is an angle subtended by a contact. Now subtended is just a fancy word that say where is it, then it a touching. So it a touching here and it a goes around and then it's a touching over F1. As can you see at the first diagram. So subtended beta angle is a 135 degree. So the angle in here we call beta is B. That can be greater than 2 pi if the rope or bed goes around a couple of times. So if you can see at the right side, I mentioned if there not friction, F1 is equal to F2. But if there is a friction, when I have here is the bed is tending go this way anti-clockwise. And but if it slip, that means the slip this way clockwise. So your friction is going oppose the motion. So friction is going this way anti-clockwise. With a friction, there is, you just think about if got F2 coming from clockwise and friction and F1 going the way anti-clockwise. So F2 has to be bigger than F1. How much bigger is the question. So if you take just a piece of bed, so one little bit of bed, and I draw the free body diagram of that. If you can see free body diagram, I have some tension over there and a little more tension over there. Means the left side and right side have a tension. So now we cannot do this as just a sum of a force of X and Y at a large level, because friction goes all the way around anti-clockwise. And this is not moment. This is friction acting X tangent and acting Y tangent. It's force acting in all kind of a different direction. So add it up using calculus. So we going to take this as this delta, and delta goes the way around, which is where you get to O to beta when you do the integral. And it is available for you on our learning management site. All the calculus, you get a nice little formula. The ratio of the two tension is E time with a power of mu time with beta. You can see the formula F2 over F1 equal to E time to the power of mu and time to the power of beta, where the mu is a coefficient of static friction or kinetic friction depending on whether is actually slipping or about to slip, and beta is an angle. Now in the process, of going all this, you have to deal with the fact that beta has to be radiant, because one thing that we use on the formula here is a arc length formula. Thank you.